Okay, so this is math board number 4. Okay, you're writing a report on video games. You are including the fact that a specific video game was downloaded 1.4 times 10 to the 8th times in a particular year, and 1.6 times 10 to the 8th in the next year. What's the sum of this data? Okay, well, here's something that you need to know, that when you are adding something that is in scientific notation, so I'm going to use these same numbers, but I'm going to make the bases a little bit different, the exponents rather. So if I have 1.4 times 10 to the first, 1.4 times 10 to the first would be 1.4 times 10, which would just be 14. And if I had 1.6 times 10 to the first, I'd have 1.6 times just 10, which would equal 16, and then I could add those together and I get 30. However, if I wanted to rewrite this into scientific notation has one digit and then a decimal. It has a digit in the ones place followed by a decimal. So this would need to be 3.0, but obviously 30, 14 plus 16 equaling 30, is not the same as 3. So we are going to have to multiply it by a base of 10. What I did to change 30 into 3 is I moved the decimal place once to the left. I made the number smaller. Therefore, I'm going to need to make the exponent bigger. When I write 30, it's really 30. If I told you write it with the base of 10 times 10 to the what, it would have to be 10 to the power of 0, because this is 1 and 30 times this is still 30 because it's 30 times 1. However, since I took the decimal place and I made this number smaller, I have to make the exponent bigger. So how can I take 3 and turn it back into 30? I can take 3 and turn it back into 30 by multiplying it by 10. So that would be 10 to the first. In other words, I took 30 times 10 to the power of 0, and I changed this 30 into 3. I made this smaller, so I needed to make this bigger. So that would be 3 times 10 to the first. Well, oh my gosh, how can I avoid all of that? Well, if this is the same as the other base 10, this was 10 to the first and this is 10 to the first, notice that all you have to do is add the numbers together and keep this part exactly the same. It still ended up being 10 to the first. So if I have 1.4 times 10 to the 8th, and I'm adding that to 1.6 times 10 to the 8th, this part can stay the same, just like this part stayed the same, okay? And all I need to do is then add this part. So 1.4 plus 1.6 is 3.0 times, this part is now staying the same, 10 to the 8th. Well, they don't have the 0 part, but they do have this, 3 times 10 to the 8th. Number 2, evaluate this expression based on x equals 10 and y equals 2. So that just means substitute the numbers in. This means x times 10, so that's going to be, this means x times y, so that's going to be 10 times 2 minus 2, all divided by 3, minus 3. So using order of operations, I do what's inside the parentheses first. So I'm going to get 20 minus 2 divided by 3 minus 3. Okay, well, here's a fraction essentially, and essentially this is a group. It just doesn't have parentheses, but it is a group, so this is what we do first. So we'll have 18 divided by 3 minus 3. And then continuing the order of operations, we divide before we subtract. So we will have 6 minus 3 equals 3. That's A. I owe my friend $200. I am trying to cut my debt by 25%. Which of the following expressions represents my debt as an integer after it was reduced by 25%? Okay, so first off, I owe my friend. So that's why all of these start with a negative 200. I'm $200 in the hole. Okay, and what I'm trying to do is reduce how much I owe by 25%. In other words, by a quarter. I'm trying to reduce it by a quarter. So if I take 200, how do I figure out what do I reduce it by? I take 200 and I multiply it by 1/4. So that will give me 200 over 4. So let's look at these, because I'm reducing it by a fourth, right? This is 200. I'm not going to worry about the negative part for a second. We're going to talk about that in a minute. But this is the 200 divided by 0.25. That's not going to be good. This is also the 200 divided by 0.25. I'm dividing it by 4, right? Because it's 1/4 of what I'm doing, a quarter, 25%. Now let's think about it. If I am trying to, I either have this option or this option, okay? Because everything else is the same. So how do I choose between these two? Well, think about it. If I am reducing what I owe, I'm not paying it all off, but I'm only paying part of it off. So I'm still going to owe a negative amount. So I'm still looking for this to be a negative number. However, if I add another negative number, incidentally, this would be negative 50. If I add another negative 50, then this is going to go up to negative 250. Okay, well, this says I owe more than I borrowed, or, more than I currently owe. However, if this is 50 right here, if this is negative 50, sorry, and I subtract negative 50, well, really what I do when I subtract a negative is I add. So this is negative 200 plus 50. This would be negative 150. This is the representation. 4 out of a group of 9 friends attended the haunted house. About what percent attended? Okay, 4 over 9. If I need to convert that into a percent, I'm going to say 9 goes into 4 how many times? All right, so you can work that out, but I also know a trick. Anytime you have a number over 9, so for example, 1 over 9 is 0.111111 repeating. Okay, all that's repeating. 2 over 9 is equal to 0.222222222 repeating. 3 over 9, which we know is 1/3, and we already know that 1/3 is 0.33333 repeating. 4 over 9 is going to be 0.44444444 repeating. It says about what percent. To get a percent, you take the decimal and you multiply it by 100. So I would say this is approximately 44.4%. y1, or number 5, y1 and y2 are functions. y1 is this equation. y2 is represented with the table. Which of the following is true about the rate of change of these functions? So rate of change is the same as slope. In y1, m is equal to 5. In y2, m is equal to, well, I don't know. We've got to figure it out. So I'm going to use these because this is the one that has the 0. And it's always one of them minus the other. It doesn't matter the order as long as you're consistent. So I can say negative 1 minus 1 over, right, because this is the change in y. This is the change in y, and slope, as we know, is the change in y over the change in x. So I'm going to say negative 1 minus 1. Now I said this minus this, so I have to be consistent. If I said this minus this, then I have to say this minus this. So negative 1 minus 0. That's going to be negative 2 divided by negative 1, which is going to be a positive 2. So y sub 2 is positive 2. So there's the slope of that one. And y sub 1 has a slope of 5. Okay, now we can compare. The rate of change for y1 is greater than the rate of change for y2. So 5 is bigger than 2. That's true. The rate of change of y1 is equal to the rate of change. No, 5 does not equal 2. That's not true. The rate of change in y1 is less than y2. No, 5 is not less than 2. The rate of change of y1 is double the rate of change of y2. Well, y2 is 2. Double that, it would be 4. It's not 4, it's 5. So that one's not true. So it was A.